self-radical equations. So here, it tells you the steps. Step 1 is to isolate the radical expression on one side of the equal sign. Put all remaining terms on the other side. So in other words, so step 1 is to isolate one radical to one side of the equation. And the typed words on here will say more. Put all remaining terms on the other side, right? So I'm just writing out what, like the bare minimum of what these steps say. You can print out these steps. So it's already done. The radical is already sitting on one side and everything else is already on the other side. So done. It's already done. Step 2 is we want to get rid of the radical. So I love math because you could get rid of fractions if you want. You could get rid of things in the denominator you don't like. We could get rid of radicals. How do you get rid of a radical? Square it. Because if you square something, you just get the inside, right? By squaring. And if you square one side, you must square the other side. So here I have the square root of 8x minus 23 equals to x minus 2. Sorry if I'm writing kind of fast. So if I square this side and I square this side, remember, if you have something and you square it and you take the square root of it, whatever order it is, square root it and then square it, you just get the thing in the inside, right? So here at the left side, what do we get? Right, the radical disappears. Awesome, right? That's what we want. Here, x minus 2 squared. What's x minus 2 squared?
X squared and
Is it x squared plus 4?
yeah.
Why is it not x squared plus 4? I always see students think that x minus 2 squared is x minus 4.
It's squared. Yeah, it's minus squared and then negative 4. So multiply x squared and the negative 2. So and that means it's a negative times a negative.
So is it a positive 4?
Yes.
So just letting you know, it's not positive 4 either. Right. But good try, good try. I liked how you were thinking about the negatives. So x minus 2 squared means you're doing x minus 2 times x minus 2, right? You want to do x minus 2 times x minus 2. If you do x minus 2 times x minus 2, if you FOIL it, what do we get when we FOIL it? X squared minus, and how did you get 4x? Minus negative 2x minus 2x, right? That'll give us negative 4x. And then this is where, Jesse, you said plus 4 because the negative 2 times the negative 2 is plus 4, right? The two terms don't cancel out, right? They add together. So you get x squared, and this is where I heard Eli say 4x plus 4, right? It's only if you're multiplying by the conjugate does the middle terms cancel out. This is not the conjugate. You're squaring it by itself, so x squared, these two add up together. So you have your negative 4x plus 4. So this here, the right side here becomes x squared minus 4x plus 4. A lot of students do that, what I just said, what I did here. A lot of students do that. So I'm going to even write, hells no, right? To remind you, do not do that, right? Remember, x minus 2 squared is x minus 2 times x minus 2. FOIL the whole thing out, right? Don't do any shortcuts, or the middle term doesn't cancel out. It only cancels out if it was x minus 2 times x plus 2. It was a conjugate. Alrighty. So we got rid of the radical. Awesome. Now what? So no more radicals. So no more radicals. No more radical. Happy face. So now that's no more radical, what kind of equation is this? It's just a quadratic equation, right? Now solve using what we do know. What we do know. So either solve a linear equation if it's a line, or a quadratic equation if it's EQTN, that means equation, if it's a power of 2. So is this a quadratic or is this a linear? Right, this is a quadratic. Since we have an x squared. Right? Gosh, how do we solve a quadratic? Have we learned that yet?
No, it's ahead of our time.
We just spent about 2 hours on it, right? So to solve a quadratic, how many methods are there? 4, right? So here, the first thing we want to do is set the equation equal to 0. So we're going to have to go back to how do we solve a quadratic, right? So 8x minus 23, and this is where, you remember I told you math flows into each other, right? So now we're going to set the equation equal to 0. Set equation equal to 0. How do I set this equation equal to 0? What do I do? Fix it. The 8x needs to be moved to the right. So I'm going to subtract 8x on both sides. The negative 23 needs to be moved to the right, so I'm going to add 23 to both sides. So now I have 0 on the left. The right side, which terms can I add? Which ones can I combine? Right, and what does that give me? Negative 12x. And what does this give me? 27. What am I missing? Oh yeah, the x squared. Don't forget me. So now I have the equation equal to 0. Does that look familiar?
Yeah.
Right, what do I do now?
Factor.
Right, we could factor it. If factoring doesn't work, I say do the quadratic formula, right? Right, factoring. How do we factor? What method are we going to use? Xbox. Since there's 3 terms. 2 things I multiply to give me x squared. 2 things I multiply to give me 27. What do I do? What do I get when I exit? I have 9x and 3x. Can I add or subtract that to give me a negative 12x?
You can.
What do we need to make it a negative 12x?
They both have to be negative.
They both have to be negative. If they're both negative, then I do get negative 12x. So if I put a negative and negative here, we have to be really careful. If I put a negative and negative here, will it still give me a positive 27 when I multiply it?
Yeah.
It sure does, right? So be really careful of that. Just because you want it to be negative, make sure it still works with that last number. So negative 9 times negative 3 does give you 27. All right, let's put it in a nice pretty box. What do we get when we put in the nice pretty box? X minus 9 and x minus 3. What property do we use next? We got the ZPP. Yeah, you know me.
Yeah.
So when we do that, x minus 9 equals to 0. So what is x equal to? 9. And then we have x minus 3 equals to 0. So what is x equal to? 3. Awesome, possum. Okay, so one last step with this that we have to be really careful of is that we must check our work. So if you see this here, confirm the solution by substituting them into the original equation. So this is super important because if you don't check your work, you might get the wrong answer because there are times where you plug one of these numbers into here and it doesn't work even though you did the math correctly. So really important is check your work. Okay? And in this case, it's going to work. So just for the sake of time, if you plug 9 in here, what's 9 times 8? What's 72 minus 23? 72 minus 23 is 72 minus 23 is 49. And what's the square root of 49? 7. So the answer is 7 on the left. If I plug 9 into the right, it is 7. So that works. If I plug 3 in here, what's 8 times 3? What's 24 minus 23? What's the square root of 1? So I get 1 on the left side. The right side, if I plug 3 in here, 3 minus 2 is, they work. So you're like, okay, why do I need to check it? What was your point? Because I'm going to show you work that's already done. Here is the first problem that was on this worksheet that we didn't do. We go through all the work. We find out that x equals to -4 and x equals to 2. But if you plug -4 in here, it does not work. And therefore, you omit this problem, this answer, and you say that your only answer is x equals to 2. So that's why it's really important that you check your work when you're dealing with radicals.